G'day folks, my name is Ben Rolfe and my pronouns are he and him. Today I'm coming to you from Gubby Gubby country, which you may also know as the Sunshine Coast of Queensland. Today's tutorial is an intro to Godot for audio people. Now, most beginners tutorials leave out audio entirely, and that's not because audio is an advanced topic at all. They just leave it out to make room for other things. But for the Audio Game Jam 2020, for obvious reasons, we wanted to kind of flip that script and really focus in on getting you up and running in the game engine and making some sounds, right? So today you're going to learn how to bring audio files into the game engine and play those sounds, how to play a sound in response to a player action, how to move sounds spatially around within the scene, and some very basic audio manipulation. Now this isn't a programming tutorial, but we will be doing a little bit of code today. If you've done some code before, that'll certainly help, but it won't be required. You can kind of get away with just copy pasting and that'll do for now. Now, I'm not really an audio person myself. I'm more of a generalist programmer, so apologies in advance for basically every aspect of the quality of the audio files I'll be using today. So without further ado, I'll head inside and let's get started. Okay, so just before we get started, I want to very briefly talk about downloading Godot, because you've got a couple of different options and a couple of different places you can do that. Here on GodotEngine.org, you'll see that after we've selected our operating system, we have to make a choice between the standard version and the mono version, which has C# support. I would just go for the standard version, personally. I use C# all the time in my work life, but I found in Godot that it's not as fully featured as the inbuilt language, which is called GDScript, and we're going to be using a bit of GDScript today. The other place that you can download Godot from is through Steam. I really like this because it does all the automatic updating for you when they release a new version. Of course, that might actually be something that you actively don't want if you're sort of worried that you're kind of working on a game and then the engine that you're working on kind of changes versions halfway through. So just have a think about that before you decide which version to download. Now when we launch Godot, we can see that we get this project manager here. We also get this window popping up in the background. That's fine, don't worry about it. We're not using it, but we're not closing it either. We'll just minimize that and put it away. Okay, you may or may not have this list of inbuilt projects, depending on how you downloaded the engine. What we're going to do first is we're just going to go to New Project, and it wants to know where to put it. I'm going to say put it in documents/repos, which is where I put all my stuff. And what are we going to call it? I'm going to call this AGJam tutorial. And then click on Create Folder. This should change to a nice little tick. And you need to choose between OpenGL3 and OpenGL2. Generally speaking, OpenGL3 is what you want, unless you're really keen for your game to be able to run on sort of some really old hardware, or if you're making a web game. But generally speaking, choose OpenGL3. The next version of Godot is actually changing over to the Vulkan engine, which is going to be interesting to see. Alright, so choose your renderer and then click Create and Edit. And this gets us into the game engine. So first of all, I just want to talk a bit about each of the different parts of the screen. In the middle here, we've got the view of the game we're making. Now we're currently in 3D view. Just because the Unity tutorial, which I did last year, was last year. It's been a long week. The Unity tutorial, which I did last week, was in 3D. Today we're going to make a 2D game in Godot. That's not me saying that Unity is better for 3D and Godot is better for 2D. I actually prefer Godot for both, but they're also really much of a muchness. Now, in addition to the 2D and 3D view, you've got this asset library, which we're not going to be using today. That's sort of if you want to download things like plugins. And you have this scripting window, which we will be using a little bit later on. But for now, I'm going to come back to the 2D view. Now over here in the top left, we have a little box which is currently on scene view. There's also an import tab behind that, which we'll talk about in a while. And the scene view is currently asking us to create a root node. Now, how Godot sort of is structured is that it's all made up of nodes. Everything that you use will be a node. And each scene needs to have a root node, and sort of all of the other nodes in the scene come off that in sort of a tree structure. And so we need to make a choice between these root nodes. Because we're making a 2D game, we're going to choose 2D scene. If you're making a 3D game, you'd choose a 3D scene. Or if this was like a menu or something for your game, this scene that we're making, you'd choose user interface. And sometimes you want to choose other nodes as well. But for today, just go ahead and click on 2D node. 2D scene. And you'll see here that it's created node 2D as the root node for our scene. You can change root nodes later on if you need to. Alright, I'm going to go ahead and rename this node. I just did that by double clicking. And I'm going to call it, I don't know, audio scene. You don't need to do that. I just kind of like to rename the node something other than just, node 2D. Now, directly below our scene window here, we have the file system. Now, this is just all of the files that we're using in the game. And so let's go ahead and import the audio files that we're going to use. Feel free to use my kind of terrible audio files if you want, or your own. Just make sure that they are in either WAV or OGG format. Now, WAV is probably the better choice, but, we're in a distributed game jam right now, and if you're sending files all around the world to each other, then you might find that compressing them to OGG first might be easier, and it's not going to make a whole great deal of difference in terms of quality, really, I don't think. So, in order to input our sounds, first of all, let's create a little folder for them. Now, all of our files in Godot appear under this res folder. And I'm just going to right-click on that and say New Folder. And I'm going to call this new folder Audio. And we're going to put all our audio files in there. And in order to do that, all I need to do is go to my folder where they are, select them all, and literally just drag and drop them onto that audio folder. Oops. Okay, so what happened there was that I actually didn't have the audio folder selected. I had the res folder selected, so it's moved them all into the res folder. I can easily just select them here. Fortunately, there aren't too many of them. And just drag and drop them onto the audio folder now. There we go. So now they're there inside the audio folder. Okay, let's go ahead and get one of them playing, and then I'm going to talk about this last little panel in a bit. But first of all, let's get one of these audio files playing. I'm going to select the node that I want to add a child node to. In this case, it's the only node that we've got in our scene. And I'm going to hit the plus button. And now we've got a whole choice of all different kinds of nodes. And if we kind of expand these out, this is actually all of the different kinds of node that exist in Godot. Generally speaking, you're going to want to use the search bar here. So I'm just going to search for audio, and we'll see all of the different audio nodes that we have available to us. There's only a few. We have an audio stream player, an audio stream player 2D, and an audio stream player 3D. And the only real difference between these three kinds of nodes is spatialization. So audio stream player has no spatialization, so whether we use it in a 2D or a 3D game, it's just going to come straight out of our speakers. Audio stream player 2D and 3D exist within the world space, right? And as they move further to the left or the right or further away, you're going to hear them from the left or the right or further away. We're not going to be using Audio Stream Player 3D today because we're making a 2D game, but it functionally works really very similar to Audio Stream Player 2D. So if you're planning on making a 3D game, what we're doing today is still going to be relevant to you. But for this first audio player, let's just attach an Audio Stream Player to it, the non-spatialized one. So click on that and then click Create. And you'll see here we have an Audio Stream Player. Now at the moment that's not playing any of our sounds. In order to make it play one of our sounds, we need to have a look over here at this right hand panel. Now this inspector panel is going to show you the details of whatever node it is that you have selected. So if I select my audio scene node here, you'll see that we've got some properties there, and if I select audio stream player, then we get a different set of properties because audio stream player is a different kind of node. Now let's take a quick look at what those properties are. The first one here is stream. It's what is the audio file or the audio clip that this audio stream player should play. And what we're going to do is just grab one of these files, going to grab bum bum, and drag it across and drop it onto the stream there. And so now that audio stream player is going to play that particular clip. The next up is volume. Now, one of the nice things about Godot from an audio person's perspective is that they've gone to some effort to try and use the terminology and the concepts from the audio world. So as a programmer, pretty much everything I've used in the past has had a volume scale that's been like from 0 to 1 or 0 to 100%. And so when I kind of first came across this volume in decibels, I was like, wait a second, what's a decibel? In your position as audio people, you're probably going to find this much more comfortable, and I think it's a great sort of step to working to having audio people work within the engine. If you're not familiar with decibels, basically 0 means that the sound plays at full volume. And every sort of 6 steps below that you get kind of halves the volume. So minus 6 decibels is half as loud, minus 12 decibels is half as loud as again, so like a quarter as loud. With that logarithmic scale, you technically never get to complete silence. The sort of boundary at which you stop being able to hear a sound is somewhere like, no chance of hearing it, is somewhere between -60 and -80. So I think that the minimum that Godot will let you have on volume is -80, and that's functionally silence. This little sort of reset to default button will put us back to 0. You can also amp the sound up a bit if you want to. Not sure if that's a good idea. Okay, so volume, obviously. Pitch scale, that changes the pitch of the sound and also how fast it plays. And then we've got a few different options here. Now playing will actually let us play and hear the sound right here in the engine. So if I tick that now, we hear my lovely dulcet tones. Just going to let that play on for a minute, because we'll see there that it's cut out. So at the moment, the sound isn't looping. And if you sort of look here, you'll notice that there's no option for the sound to loop. So we're going to get to that in just a minute. In fact, no, let's get to that now and we'll come back and talk about these other options. So in order to make a sound loop, what you need to do is actually change how it's imported. So whether a sound loops or not is actually part of the audio clip, not part of the audio player. So the two sounds that I've got here that I want to loop are these first two, this ah and the bum bum. Now, in order to change the way that they're imported, we select it and then come up here to this import tab. So you can see here that we're working with rr.wav, import it as a wav, which is the only way to import it because that's what it is. You can force it to be 8-bit mono, set the max rate, you can trim it, normalize it, and here's what we want, loop it. So we're just going to tick that. You can also change whether or not it's compressed. You might get different options to these if you brought in an OGG file rather than a WAV file. Okay, so I'm just going to tick loop, and then I'm going to make sure that I hit the re-import button. And that just brings the file back in with looping turned on, essentially. I'm going to go down to bum bum and do exactly the same, tick loop, re-import. You can select multiple files and change a value on multiple if you've got a whole bunch of files that you need to change one of these things on. Yeah. Okay, so now if I tick playing, Hopefully, when we get to the end of this loop, it'll just loop around and start playing again. And there it is. Generally speaking, you're not going to want to have playing on, because it means that, you know, all of the sound files in your game are going to be playing all the time while you're trying to be developing, and that can be a pain. But it's nice to be able to just, like, yeah, turn that on and off when you need it. Autoplay means that, you know, this sound is going to start playing automatically when the game begins. And in this case, yeah, that's absolutely what we want to happen. Stream paused, we'll pause the sound. Let me just... So that as I pause it and unpause it, it plays from the same position. If I stop playing it and start playing it again, it'll replay from the start. We can go to different mixes. You probably know a hell of a lot more about that than I do, so I'm not going to talk about it. And also we can choose which audio bus this sound is playing through. And we're going to talk a little bit about that later on in today's tutorial. So for now though, we've put that sound in, we've dropped, we put that audio stream player in, we've dropped the sound file into it, we've said it's automatically playing. Now let's just run the game and make it happen. First thing I'm going to do is save my scene, either through the menu here or just by hitting Control-S. And it wants to know where to put the scene. I'm going to create a folder for scenes. Obviously for this tutorial I'm just creating one scene, but it's good practice to have sort of all your scenes in a folder. Because I renamed that root node to audio scene, it's suggesting that that's what I want to call my scene file, and that works for me. Okay, now the other thing that's going to happen when we click play for the first time is that it will say, hey, you haven't selected a main scene yet. And you can always change this later in project settings, but do you want to define one right now? And yeah, sure we do. Select, and we're just going to select the one scene that we have and click on open. Okay, and now the game's playing. This is our game. Looks pretty boring. Sounds arguably even worse. But yes, that's an audio player in action. Next thing I want to show you is how to do spatialized sound. But in order to do that, we're going to need something that moves around our scene. So what I'd like to do is just to create a simple little game where we have a sprite that we can move left and right using the left and right arrow keys. Okay, you'll see that when we played the game, this output window, output panel popped up. That's just telling us a few things about how the game is running. From code we can kind of add debugging comments in here if we want. In order to close that, we just click on output down here and that'll close down. In a little while we're going to talk about the audio panel, as I said, the different buses, and we're also going to talk about animation, which is sort of how we sequence clips together. Okay, but first of all, let's just get this sprite moving back and forth with the arrow keys. Now, just to look a little bit closer at this scene view here, by using the mouse wheel, we can zoom in and out, and by holding down either the right mouse button or holding down the mouse wheel, we can drag that view around. I find that I generally hold down the mouse wheel, I guess because I'm using it to kind of zoom in and out and then also to drag it. Either way is fine. This red line here represents the x-axis, left and right. This green line here is the y-axis, up and down. And you'll see that they meet at this point, which is the 0x0y point, and that's in the top left of our scene. And we'll talk about that a little later on. Also notice that there's this blue box here, sort of very faint. If you've got a color vision difficulties, that might be very hard to see, I imagine. Now that's the window essentially of our game, and we can change the size of that if we want, and I'll show you how to do that. We come up here to project settings, and a bunch of different options here. But if we scroll down a little bit, we'll get to display window. And clicking on that will give us a bunch of different options about the window. And you'll see here that our current width is 1024, and our current height is 600. I'm just going to change our current height to 512, just because it's half of 1024, and I'm going to play a little bit with that later on. You can also set things like whether it's resizable, borderless, full screen, etc. Okay, so I've made that change. Don't need to click save or anything, it automatically happens. I'm going to click on close. So because I didn't make a big change, you probably won't have noticed there, but that blue box has become a little bit less tall because I changed it from 600 to 512. Okay, so our game happens within that blue box essentially, and if it goes outside of that blue box, the player won't be able to see it. So let's create a sprite that we can move around. Now, obviously, you can bring in your own sprites if you want. I'm just going to use the one that comes automatically in any Godot game, which is their little icon here. And I'm just going to drag it from our file system into somewhere in the middle of that box. Now this is Godot's icon, little robot. I don't know if it has an identity. I like to call it Robbo, spelled R-O-B-O-T, because I'm hilarious, and so that's what I will be calling it today. Okay, so if I click on that, you'll see that we kind of get the ability to resize it with these handles. I'm going to mess it up, and I'm just going to Control Z to undo that because I don't want it. And we can also drag it around. Now, if I come over here to our inspector and open up this transform set of values underneath node 2D, you'll see that we can see its X and Y position. And as I drag it around, as I drag it up near this sort of point where the X and the Y axis meet, you'll see that that point is 0, 0. Notice also that our sprite is referenced from the middle of the sprite, not the top left corner. We can actually change that if we want in the offset. So depending on how you've got your game set up, you might want it centered, which is the default, or you might want the position to be based on that top left point. For us, I'm going to leave that on. I'm going to say that the sprite is centered. Now, as I drag the sprite over to the right, the X values are going up. As I drag it left, the X values go down. As I drag it downwards, the Y values go up. So this is a bit weird for some people. This is a sort of a Y down environment. So yeah, dragging that Y goes up as the sprite moves down, and Y goes down as the sprite moves up. I just want our little Robbo to start in the middle. So I'm just going to manually set here the X position to be 512 and the Y position to be 256, which is just half of my 1024 and 512. Okay, so we've got our little Robbo there in the middle, and if I hit the play button, then that icon comes through. Obviously that's not moving around yet, so let's get into a little bit, not too much, but a little bit of GD script. So the first thing we need to do is attach a script to our icon. And we do that just by clicking on our icon in the scene view, and then clicking on this little scroll with the plus button. Attach a new or existing script to the selected node. Now, you can attach the same script to several nodes if you want the same behavior to occur on different nodes. We're just going to be using one script today. We're going to put everything into this one script that we're about to create. So we click on that, and it says, what language would you like to use? GD script is what we want to use. Inherits sprite. So because this is a sprite node, Godot's like, okay, you want your script is a kind of a sprite script. And that's also what we want. Template default, that's fine. And it asks us what path do we want. It's trying to put it into the scenes folder here. I don't really want it in the scenes folder, but I've forgotten to create a script folder. Wait a second, can I click on this plus button? Yes. Let's create a scripts folder. Okay. Open. All right, so yes, we want it to go in resources. I'm assuming that's what res stands for. Resources, scripts, icon.gd. That's great. Cool, and it's brought us over to the scripts panel here with a default script. And I just want to talk a little bit about this stuff in here. Extend sprite, as I discussed, that means that this script is a kind of a sprite. So we can do things to it that Godot knows can be done to sprites, like change its position on the screen. We can declare some variables, and we're going to be doing that in a minute. And then there's these two functions. Oh, sorry, I should mention that this hash symbol is a comment. So if you have a hash symbol there, anything after the hash, the computer will just ignore entirely. So these comments are just here for us to read. The computer does nothing with them. So yeah, we've got currently here a function called func_ready. And it says here that this is called when the node, oh, yikes. I've got a sort of a scaled down screen at the moment because I want it to be, or scaled up screen rather, because I want it to be a bit larger for you to read. In fact, I might even go a little bit larger yet, just to make it clearer on your screens. Okay, so this function is called when the node enters the scene tree for the first time. That's kind of a slightly convoluted way of saying that when the game starts and that node's already there, or when that node first appears, this function will run. And the other function here, which is currently commented out with these hash symbols, is called every frame. And it also has this delta value, which is the amount of time that's passed since the last frame. And this is where we're going to actually be doing all our work. We're going to sort of ignore these ones. But before we get started on that, let's just make sure that Godot is actually even listening to us at all, right? We're going to create a tiny little program called a Hello World program, which is just a way of saying, hey Godot, have you actually read that script file that I wrote for you? Are you like listening to me and obeying my commands? And in order to do that, what we're going to do is come in here and underneath func_ready, we're going to type print, open bracket, open quotes, hello world. Now, indenting is really important in GDScript. If you've used Python before, then this language will look extremely familiar to you. It's syntactically very similar to Python. So what this indent means is that anything which is indented is part of this function. And then when we sort of finish the indent and come back again, that function's finished. Okay, so we're going to say func_ready, we're going to print out hello world, and then the pass does nothing, basically. That just needs to be there if we have no other commands inside the function. So we could delete that one if we want. I'm going to leave it there for now. Alright, so I'm going to press Ctrl S to save, and then I'm going to hit the play button. Okay, the game's playing as normal. We didn't see our hello world anywhere there, but if you come back here and look at the output, you'll see that that's our hello world there. It's been printed to the output, and that's what the print function does. And so that's great. That just means that yes, we now know that our script is not being completely ignored, which is handy. Now, if we did something, if we sort of made a typo and we said print without the I, then we would get an error down here describing what we'd done wrong. The method print is not declared in the current class. And it also tells us what line the error is on and what character number. And it also highlights exactly where the error is. So it gives us a lot of hints as to how we can go about fixing it up. And we'd look over this and go, oh, I typed print wrong. Okay, saving that again. All right, but like I said, most of what we're going to be doing here happens every frame. So every frame we want to check, hey, has the user got their left arrow key pressed down? And if they do, then I would like to move that sprite just a tiny little bit over to the left. Okay? And so there's two parts of that. The first part is, has the player got their arrow key pressed down? And the second part is move the sprite to the left. And in order to do that first part, we need to do an if test. And an if just looks like this. We say if, and then a certain thing. In this case, we're wanting to test if they have their key pressed down. And to do that, we say if input dot, just trying to remember on the fly here now, if input dot is action pressed, that's the one. So yeah, we're saying if input is action pressed, and then we need to, inside the brackets, we need to say what action are we looking for. And the action that we're testing, it's got here a list of all of the actions which have already been defined. The action that we want is UI underscore left. Now we can define our own actions as well. I'll show you how to do those a little bit later on. But for now, we're just going to use UI left and UI right. And those actions have been mapped to the left and right arrow keys of your keyboard, and also to the left and right of a D-pad on a controller. So yeah, so we want UI underscore left. And then we need a colon at the end of that line. Sorry, this my small window is causing us some problems. Let me just expand that out a bit. I just wanted things to be scaled up so you can read them, but it's getting a bit cramped. Okay, so that's currently causing an error. That's fine, ignore it. That error will go away as soon as we put something in here that's been indented. So if input action dot is action pressed UI left colon, then what we want to happen is that the sprite's position is going to change. And we do that just by saying position dot x, and we want it to move left, so we want to subtract something from it. And so I'm going to say position dot x minus equals. Now minus equals is the subtract from operator. It means that whatever position dot x currently is, remove this amount from it. And I'm going to start just by saying let's just remove 1 from it, and we'll test that out. I might just delete this pass because we don't need that anymore. Alright, so I'm just going to save that now, Control S, and play it, and just make sure that that's working. So if I hold down our left arrow key, we now see that our little sprite is moving left. The right arrow key currently does nothing. Now that's all well and good, that kind of works. The problem with it is that it doesn't take into account the player's frame rate. So if you've got one player whose computer is running at 60 frames per second, and another player whose computer is running at 30 frames per second, the player whose computer is running at 60 frames per second is going to be calling this function twice as often as the other player. And so their little robo is going to move to the left twice as fast as the other players. And so what we want to do is change this position.x to be subtracting an amount based on this delta value here. So it's basically the delta again is how long has it been since the last frame. And so I'm going to say, let's say 1 multiplied by delta. So the player who is has 60 frames per second is still going to be calling this twice as often, but it will have only been half as long since the last frame. So that will kind of all come out in the wash, and the two players will get the same experience. Okay, let's give that a play. Okay, if you look really carefully, that sprite is moving, but it's moving super slow, and that's because our delta is a really, really small number. So what I'm going to do is to multiply it by a larger number than 1. And rather than hard code a value in here, I'm going to come up a little bit, and here under the member variables declaration, I'm going to declare a variable. I'm going to say var, the variable, speed equals 100. And this will let us just change the speed easy later on if we decide that we want it to be faster or slower without having to sort of look through the script and change the speed in different places. So I've set speed to be equal to 100, and instead of 1 times delta, I'm just going to say speed times delta there. Again, save it, give it a play, and that's back to moving at a nice speed. So that's the left key only. Now I want to do something very similar for the right key. In fact, it's so similar that what I'm going to do is select those 2 lines, Control-C to copy, and Control-V to paste. And the only things I'm going to change are that the action that we're looking for to see if they press it, I'm changing that to UI_right, and this operator here. Instead of using the subtract from operator, I want to use the add to operator, which is position plus equals speed times delta. Another way to write that, incidentally, would be to say position dot x equals position dot x plus speed times delta. Both of those 2 lines do exactly the same thing, but I'm just going to use that subtract from and add to operator. Okay, one more test, and then we'll add our spatialized sound. Save it with Control-S, hit play, and now the left and right arrow keys are both working. If we press both at once, it stops, and that's because it's just sitting there each frame and going, alright, subtract this amount from the position.x, and also add the same amount to position.x. So the position ends up being exactly the same. Okay, so now that we've got that moving left and right, let's add some spatialized sound to that so we can hear it moving around in the scene. Just going to come back to our 2D view here. Not that it makes much of a difference what we're doing. Okay, so I want to add another audio stream player into this icon node. In fact, I might take the audio stream player that we already have and put it... can't quite do that. What I need to do is drag this icon out under audio scene and then drag our audio stream player into it. Okay, now the reason I'm doing that is I just want to prove that as we move around the scene, our audio stream player is now inside that object that's moving around, but the sound isn't moving around the scene at all. Now let's add the other kind of audio stream player, the audio stream player 2D, and see how it works differently. So I select our icon node, hit the plus button, select, you might need to type into the search bar again, I'm not sure. Shouldn't, but you may. Type audio in there again. And select audio stream player 2D this time, and click create. Now it's called, if I drag this again, having a bit of a problem with my oversized windows, or undersized, depending on how you look at it. So yes, we've got an audio stream player and an audio stream player 2D. Now over here, the audio stream player 2D has some slightly different options. Some of them are similar: stream, volume, pitch, scale, playing, all these ones. It starts to get a bit different down here. So the maximum distance is the maximum distance away that we can hear this sound. So that's distance from the center of our viewport, and it's measured in pixels. So it's saying that once our Robbo gets 2,000 pixels away, like way over here, we won't be able to hear them anymore. I'm just going to knock that down to 512. So basically what I want is that when Robbo gets to the edge of the screen, that's as far as we can hear them. Let's drag a sound into our stream here, and let's grab R, chuck it into our stream. Make sure you turn on autoplay or you won't hear it play at all. And let's just give that a run and see if we can hear it moving left and right.
Bum ba bum 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 ba bum bum.
Gonna stop that. It's just not a terribly good sound person at all, and the bum bum's a bit loud. So I'm going to come back to this audio stream player that's playing bum bum, and just reduce the volume. Just going to say -6. Right, let's give that a play now. Okay, now as you move the sound left and right, you should hear that the R is moving into your left ear, or right ear, depending which way you're moving, while the bum bum still stays centered, playing out of both ears. And then as you go beyond the border of the screen, it'll fade out completely, because we said that was the maximum distance. Now you can also play around with the drop-off. What I might do is just temporarily turn off autoplay on the bum bums, so we can really clearly hear those R's. And yeah, we can change the attenuation. So at the moment we've got an attenuation value of 1, which means that we've got this linear drop-off as the Robo moves towards its furthest point at the edge of the screen. We can click and drag this around and it'll change the way that curve is. We can say that I want it to drop off really fast and then just kind of linger, or I can say that I want it to sort of stay at full volume until it gets quite close to the edge, and then drop off fast. So I might put it there at 0.2. You can also set that value numerically if you want, just by double clicking, and then I might say let's make it 0.25. Alright, let's give that a play. Okay, and now if I come over here to somewhere like that, the volume is still pretty much full volume, but I can hear it mostly coming out of my right ear. And then only as I get really close to this edge does that sound start to fade out. Now if you want just that left-right panning, without any sort of attenuation like drop off until you get right to the edge, we can do that just by setting it to as close a value to 0 as we can. If I was to double click on that, I think it's not quite 0. If I set it to 0, yeah, it's 0.00001. But yeah, that's functionally an instant drop off when we hit the edge of the screen, and no drop off before that. So let's hit play and try it out. So yeah, coming over here, all the sounds going into my right ear, still perfectly loud, and then it's gone. And yeah, can come and go. So that's how attenuation works. I quite like 0.25 myself for this one, so I'm going to leave it at that. And let's remember to turn on our bum bum bums. Autoplay on. Now, in GDScript, in Godot, each audio stream player can only be playing one sound. Again, if you're coming from the Unity world, you'll probably be used to polyphonic audio sources, which can play multiple sound files at the same time. That's not how Godot works, so you just sort of need to get used to the fact that you need a separate audio stream player for every sound that you want to play. And sometimes, if you end up with something with a really complex sound environment, you might even find yourself sort of adding and removing audio stream players using script, just because you might otherwise have so ridiculously many of them. In order to kind of keep things clear as to which player is playing which sound, I'm just going to name these players after the sounds that we're playing out of them. So I'm going to call this audio player Bum Bum, and the spatialized audio player RR. Now that's all well and good if we just have sort of these simple loops that we want to start at the start of the game and just keep on playing through. Generally speaking, we want something a bit more complicated than that. And so I want to show you how to use a tool in Godot which is like a visual sequencer, which comes under animation here. So let's let's click on animation, and it'll tell us that we need to select an animation player node to create and edit animations. We don't have one of those, so let's create one. So I'm going to attach this again. Just this node is going to come off my icon node. So I select my icon node, click plus, and we want apparently an animation player. There it is. I double clicked on it that time. You can click on it and click OK or whatever, or just double click. Okay, so we have an animation player here. I'm going to double click on that and rename it music, because this is going to be our sort of music, and I'll add some sound effects in afterwards. Okay, so now that we have our animation player node selected, you will see it's no longer giving us that, that sort of warning down here that we need one. But we're not getting a whole lot else, right? We need to create an animation on this animation node. Now to do that, I just click on an animation here, and then click on New. And it would like a name for this animation, please. I'm gonna just call it Music as well. And now we've got this sort of track layout here, and we don't have any tracks in it yet. Let's add one. When we add a track, it says what kind of track would you want, and there's a whole bunch of different ones you can use, because this animation tool, as the name would apply, is not just for sequencing music, it's also for doing animations. And what we're going to choose is an audio playback track. And it says pick the node that will be animated. So it's saying which audio player does this audio track apply to. So let's start with Bum Bum. Okay, so we've got here Bum Bum, and Bum Bum currently has no audio clips in it. So this animation player is going to override the stream that's already in here. In fact, I might just completely remove the default stream that's in there. I might do the same with R. Don't really need to do that. I just want to, I guess, demonstrate that it's no longer using this stream value. It's using whatever we put in here. Okay, so Bum Bum needs some audio clips in it. So let's just drag Bum Bum into here. And there's the clip. We can drag it back and forth. By default, the snap value here will be 0.1 of a second. I don't need it to be that fine. Ooh, I'm just going to say snap to every second. There we go. That's probably more convenient for me right now. Also notice this grey area. This means that the audio animation rather is only 1 second long. Right? We can't drag that out any further. In order to change the length, we need to come over here next to the little clock and set how long we want this animation to be. In my case, I'm going to want it to be 16 seconds. I also want to zoom out a bit. What I'm doing here is holding down Control and using the mouse wheel. So I just want to scroll out so that we can see that full 16 seconds. Okay, and as you can see, our Bum Bum clip only lasts for half of that, so I'm going to drag another Bum Bum clip in and align it there. Okay, so that's great. Our Bum Bum will be playing that Bum Bum clip twice. And that will be, because this is a non-spatialized node that it's playing it to, that will be non-spatialized sound. Now let's add another track to the R, and let's add the R clip to that R track. And just drag it, make sure it's aligned. And so that sound will play out of the R node, which is the spatialized sound. Finally, I'm going to add one more playback node so that we can play some clicks out of it. So again, I'm going to select icon hit the plus button, type in audio because we want an audio stream player. And do I want the clicks to be spatialized? Let's say, I don't know, let's say nah. So I'm just going to add an audio stream player to it. No, I do. I want them to be spatialized. Because let's try spatializing them differently. So I'll add an audio stream player there. Again, inside of icon, I'm going to rename it clicks. Then, let me just expand this up a bit. Then let's add another track, another audio playback track to our clicks node this time. And let's just drag these clicks in. So what I want to do is just this 3-click a bunch of times. I've found before that, yeah, copy paste doesn't really work there. And it's even got a duplicate keys option, which doesn't seem to work either. So I've just found myself dragging in multiple times, which is a bit of an annoyance, but not the end of the world. Let's have a 2-click right at the end. Yeah, let's leave it like that. Is that just a bit of a visual glitch there, that line? I think it is. Okay, so let's just click on the clicks sound, audio stream player rather, and just change a couple of things here. So again, let's set the max distance to be 512. And this time around though, let's increase the attenuation. So let's make it drop off faster. Let's say 2. So as we go out towards the edge of the screen, our RRs will linger, but our clicks will drop off quite quickly. And that's just, I guess, to demonstrate the differences that you can do by changing the attenuation values on different players. Now, I haven't turned autoplay on. Again, that's going to be controlled by this animation clip, animation track. In fact, I'm going to come here and I'm going to turn autoplay off on each of those streams. Alright, let's try hitting play. And currently we've got nothing. And the reason for that, I mean, we've got a little robo moving left and right, but we've got no sound playing. That's because autoplay is turned off and we have no streams to play anyway. And this music player hasn't automatically started playing. In order to make this player autoplay, what we need to do is click on this funny little kind of arrow with an A inside it. And as I hover over it there, it says autoplay on load. So I'll click on that and you can see now that next to my music animation, it's marked that as an auto-playing animation. What I'm also going to do is click on this looping icon, because again, once it's in an animation player, it'll ignore whether the file is a looping file or not. It'll just play it according to the positions that you've put it in here. So I'm going to click on that animation looping. Alright, now let's give that a run. And there we go. We've got the 2 tracks, well 3 tracks, the bums, the R's and the clicks. Now as we go to the right or left, so that those clicks have really dropped off quite a lot. The R's are still sustained. As I get out near the edge, the R's will drop off as well. And the clicks are pretty much completely gone by this point. Okay, so that's basically how to use this animation as a visual sequencer. Now let's say that we want to let the player press a button and for it to make a sound when they do that. So this kind of mimics how sound effects might happen in your game. And so we're going to make it so that when the player presses, let's say, the control key, it will play this pa sound, and when they press the alt key, it'll play the tf sound. So in order to do that, we need to define a couple of actions. Before we used the UI underscore left action and the UI underscore right action, which were predefined. But there aren't any predefined actions that map to those control and alt buttons. So let's add some in. To do that, we come up to Project, Project Settings, and then in the tabs along the top, we want to select Input Map. And we can see here all of the actions that have been previously defined. Some of them are tied just to keys, some of them have been tied to keys and also to controllers. Okay, so let's create a new action. Up here, I'm going to call it button underscore pa, and click on add. And down here you'll see that pa has been added. It's not tied to any keys yet. We'll do that in a second. First of all, I'm going to add that other button, button underscore tuf, and add that. Okay, so down here now with button pa and button tuf, let's tie them to some keys. So click on this add event, and you get the option to tie the action to a key, a joy button, like a controller button, a joy axis, or to a mouse button. And so we're going to just tie it to a key for now. Unless you've got a controller and you want to connect it to that, that's fine too. So it tells us to press a key. I'm going to press the control key and say OK. And now we've got that control key bound to that button underscore pa action. I'm going to press add event again next to button tuf and press the alt key and OK. And now that's been bound to the button tuf action. And so now we can use button underscore pa and button underscore tuf in our code. Now, in order to play sounds when the player presses those buttons, we need a couple of other audio stream players here. Let's have non-spatialized ones this time round, just for kicks. Alright, so I'm going to come up here to icon and add a new child node, audio stream player, and I'm going to name this one pa, and I'm going to let's go on, widen that. Oh, I can't. Why can't I widen that out? Okay. Alright. So yeah, let's make sure this time around we're not using that animation controller to control what sounds it's playing. So this time around I need to drag pa into the stream. And I don't want it to autoplay, right? Like I don't want it to go pa as soon as we start up. And also the pa sound, if I look at our import settings, is our non-looping sound, because I don't want it to go pa 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 as soon as the player presses a button once. Okay, so it's it's not playing, it's not automatically playing. That's all fine. I come back here to scene and do exactly the same thing. Add audio stream player, and call this one TUF. Did I make that other one an audio stream player 2D? No, cool. Call it TUF, and we're going to drag the TUF sound into there. Okay, so if I play that now, nothing's changed, right? There's still no pa and TUF sound. I'm pressing Control and Alt, and nothing's happening. Okay, so we need to write a little bit more GD script to make to tie those actions to playing those sounds. Okay, so let's come over here to our script again, and again just drag everything away to give us some more room to see here. All right, so here we're going to say basically exactly what we did, the same kind of if test almost, in order to check whether they have just pressed the control button. And then we're going to do something quite different though in order to play the sound. So again, making sure that our indentation is right. We want to be indented like inside this function, but we don't want to be indented inside this if statement. We want to be right here. And we want to say if input dot, as I start typing is here, we can see that there is a thing called is action just pressed. So is action pressed will check whether that button's held down at all. Is action just pressed is saying was that button just pressed down this frame? And that's the one we want, because we don't want this to be running every single frame while the button's pressed down. That's what we wanted in this case, but we want for this sound effect is action just pressed. And in here we put the name of our button in quotes, button underscore colon, and an indented block. So if that button is pressed, then we want this pa audio stream player to play a sound. Now our script is on this icon file here. On this icon node here. And TUF is a child of this icon node. And one nice easy way in Godot to get access to a child node is just using the $sign operator. So we can say dollars, and it gives a list here of all of our child nodes. And so I want to say if dollars pa, I want to say dollars, not if, we've already done the if. I want to say dollars pa dot play, open and close brackets. And that's all there is to it. We've already set the pass sound into the pass stream, so we don't need to tell it what to play. We just need to say, hey, play that sound, please. And I'm just going to copy and paste that block of code because, unsurprisingly, our TUF button works almost exactly the same way. We want to say if the action was just pressed button underscore TUF, then $sign TUF dot play. I'm going to save that and give it a play. So those sounds that we had are already playing. But if I press Control or Alt now, I can do a bit of beatboxing with it. You might have also noticed there that the first time, I don't think it's just my ear, the first time that played through, there seemed to be a slight synchronization issue. I'm actually not sure what's causing that at the moment, and it seems to sort itself out. So I'm sorry, but for the moment I'm just going to pretend that's not happening because I'm not sure how to deal with it, quite frankly. But yeah, it does seem to sort itself out. So I assume it's got something to do with preloading those audio files. I just don't quite know enough Godot to figure out exactly what's going on. Okay, so we've got some spatialized and non-spatialized sounds playing. We're moving our little robo left and right and playing sounds from their location. We're playing some sounds in response to the player pressing a button. What I might do just before we finish up is modify the sound. Oh, I need to get to buses at some point as well, rather. So before we get to buses, though, I might have a play around with modifying a sound, just some really basic kind of tweaks. So if we have a look at at one of these audio players, what I'm going to play with is this pitch scale value. If I press playing that, if I turn on, oh, it doesn't have a sound in it. Let's put bum bum in there for a minute. If I play around with the pitch scale, oh, if I press playing, play around with the pitch scale, we can get a bit of Alvin and the Chipmunks going on, or I can be talking really slow. Okay, so that's what we're going to play with script. Let me turn that off. And again, I don't really need to do this, but I'm just going to remove that that clip from the audio stream player. Just kind of, I guess, as a reminder to myself that that's being controlled somewhere else. It's being controlled from the animator. Okay, so what I'm going to do is I'm going to tie, we've got the left and the right sort of controlling our positional sound. What I'm going to do is tie this up and downness to the pitch scale. So I'm going to, first of all, add a bit of code that lets our robo move up and down. So back in script, I'm just going to put a bit of a gap between those movement things and the button things. So here, what I'm going to do is add two more blocks just like these ones. I'm actually just going to copy and paste those first two blocks and change a few values. Okay, so when they press left, take a bit away from position.x. When they press right, add a bit to position.x. When they press up, we want to take a bit away from position.y. So remembering this is a y down environment. So if they're moving down, we add to y. If we're moving up, then we subtract from y. Okay, so if they're pressing UI underscore up, position y, subtract speed times delta. And similarly, if they're pressing down, position.y plus equals speed times delta. Let's just give that a run, save and run, make sure it's working. Cool. There we go. So we've got two-dimensional movement. You'll see as I move up a lot that the somewhere up there off the screen, the attenuation's still happening. So even though the it's not sort of fading to your left or your right ear, it does still drop off with distance as it moves up or down. But there's a lot more horizontal distance in our window than there is vertical distance. Okay, so that's all well and good. But what we want to do somewhere in here, and let's do it in here after all these things, is that we want to change the pitch according to the position of Robo. And so let's just say that we're wanting to set that pitch to be a value between 0 and 2. So if they're at the very bottom of the screen, then we'll set the pitch to 0. And if they're at the very top, we'll set the pitch to 2. And if they're right in the middle where we're starting them off, we'll keep the pitch at 1. So in order to work out what that value is, let's say, well, first of all, the thing that we're wanting to change the pitch on. We want to change the pitch on several of these different audio stream players. So first of all, I'm going to create a variable to store our new pitch in. Say var pitch equals 1. And then I'm going to say $bum bum dot pitch underscore scale equals whatever our pitch value is. I'm going to do exactly the same for RR. $RR dot pitch underscore scale equals pitch, and I'm going to do the same even for clicks. Clicks dot pitch scale is equal to pitch. Okay, now at the moment that's going to do nothing, right? Because we're setting them all to 1. If I did change this to 2, save this and run it, then all of those sounds are playing at 2 speed. So somewhere in between declaring this variable and using it to set the pitch scale of all of our stream players, Let's set the value of that pitch based on on our position.y. So if we were to say, so I don't need to do it between, let's just do it in that same line. If we were to say that pitch equals position.y, that will be giving us a value between like 0 at the top or 250, or 512 at the bottom. That's not quite what we want. What I want to say, 256 minus position.y. So at the top, that means it will be 256. At the bottom, it will be 256 minus 512. So minus 256. We're starting to get close. Going to divide that by 256. And so now it's a value between 1 negative 1, and I'm just going to put a 1 plus at the start there so that it's a value between 0 and 2. Generally speaking, I wouldn't sort of hard code these numbers in. I would be looking at I'd be asking Godot what height the screen is by saying get viewport rect dot size dot y is how you could do that if you wanted to. For the sake of simplicity, I'm just going to leave this as it is for now. So we're setting the pitch to be 1 plus 256 minus position.y divided by 256. And yeah, if that's too much maths for you, don't worry about it. Trust me, that's going to give us a number between 0 and 2, which we're then going to apply to the pitch of these sounds. Let's give that a run and see if it works. Okay, in the middle, it's working out fine. As I go up, that's speeding up. Now, have I still got these looping? I think I do. Yeah, okay, let's turn off these loops, just because they're stopping me from demonstrating something that's going on. Alright, let's play this again. Okay, if I speed this up a bit, you'll see that things are going out of sync. What's happening is that we're changing the speed at which a clip is played by speeding up the pitch. So say if we set the pitch to 2, this clip here will play in half the time. So it'll be finished at the 4-second mark. But it won't cue to start the next clip until the 8-second mark. In the meantime, this one will keep on playing until the 8-second mark, but then will stop and won't start playing again, until the end of that loop. And these ones will play sort of in 1-second lengths with 1-second gaps between. So that's really not what we want. When we're speeding up the pitch, we also need to speed up the speed at which these animation cues are coming in. Fortunately, that's a nice, easy thing to do. And we can just use our pitch value again. What we're going to say is we want access to this music node here. So we're going to say $music dot something like speed playback underscore speed is equal to pitch. And save and run that. And so now you see that even sped up, everything's staying in sync still. Okay, so that's a bit of fun there. You might be able to use it for something a bit more useful than just silliness. But let's have a bit of a play now with audio buses. And I promise no more scripting today. So let's get out of this script window, back into this 2D window. I'm just going to move this music player just down a bit to between. So yeah, the music player kind of applies to all of those above and not to the ones below. It just works better in my head. Anyway, oh, I should have mentioned there just while we were mucking around with the pitch, because I didn't apply the pitch to pa or tuf. Let's slow this right down. Those are still unaffected by those pitch settings. Okay, right, back to buses. So if we have a look at any of our audio stream players, we can see that they are by default going towards this master bus, which at the moment is the only bus we have. Let's take a look at our buses in the audio tab here. Okay, so we've got a master bus. We can add our own buses if we want. So one sort of common thing to do might be to split up our music onto one bus and our sound effects onto another one. So I'm going to add a bus. It's by default called new bus. I don't want it to be called that. I want it to be called music. And I'm going to add another one and call it effects. Now, by default, each of these is feeding directly into the master bus. We can, using this drop-down, change a bus to feed into any other bus which is to its left. So I could, if I wanted to, feed effects into music, which would then feed into master, which then go out to the speakers. In this case, that's absolutely not what I want to do. I do want both of those independent buses to feed directly into the master bus. Now you'll see that we have the ability to control volume here. That's something which you can absolutely change using script. We won't be doing that today. It's easy to do. Maybe we'll do it right at the end. I'll just show you the line of code that does it at the end. Okay, now one thing which bugs me a lot is that I can't just type a value in there. I've got to like slide it up and down until I get it right. And if it's annoying you as much as it annoys me that you can't get to 0 again, then you can just click on this thing here and reset volume to 0. But I would really like a text box there. Okay, so at the moment, all of these audio stream players are still feeding into the master bus. So let's just go through each of them and change which bus they're feeding into. So I want bum bum, and clicks all to feed into my music bus, and I want pa and tuf to feed into my effects bus. And just to make sure that's working, let's sort of try just messing with the volume a bit. Let's turn music like right down to -8 or something, and give that a run. So I've got quieter music, but the effects are still loud. And if I do the opposite, let's reset the volume of the music bus and quieten down my effects bus. Got louder music and quieter effects. So we know that those buses are working. Obviously, oh, don't want to delete it, reset volume. Obviously, yeah, changing the volume is one very useful thing that we can apply to a bus. Another thing that we can do is add any number of effects to that bus. So let's just say that you're making like a top-down old school Zelda style RPG where you're running around and your player's making footstep sounds as they run, and they go into a cave and you want to kind of give a bit of echoiness to those sound effects. What you could do is add an effect to that bus, and I mean, this is we're getting into territory which is very much not my
Not my forte, so this isn't going to sound like a proper echo. You'll probably be much better at making it sound like a proper echo. So I'm just going to put a bit of reverb on this sound effects bus. And we can see that, yes, this effects bus has reverb. If I click on reverb, then over in the inspector I'll be able to change some of those qualities. I don't know really what any of these things do. I'm just going to leave it like that for a moment. It's going to be way more reverb than we want, I think, and give that a play. Okay, so the music is not reverbing, right? That's on a separate bus. Sound effects, whoa, yeah, like I said, more than we want, but you know, it's got a bit of dark, spooky cave to it going on, and you can muck around with these values to change those. Let's just, I don't know, I did have a play around a bit before. Let's give a bit of high pass. Let's drop the wet a bit. And let's make it a smaller room. I think those kind of made it a bit less extreme from memory. Oh, still quite a bit. What about just dropping the spread a bunch? Am I actually changing the right one? I am. Again, like I say, I don't know what I'm doing. It is changing things, just not radically. Okay, that's a bit less extreme. But as I say, I don't know what I'm doing, so I'm going to stop trying to teach things I don't know. You have a play around with that. So before we finish up, I will just very quickly show you the code, the line of code that if you want to change the volume of a bus, or if you want to turn off or on an effect that is on a bus. So we'll try quietening down the music, and we'll try turning the reverb off through script. Okay, so let's change the volume of our music bus up here at the beginning. So inside our ready function, so when the game starts up, let's leave our print hello world in there. Let's get rid of that pass, though it's just annoying me now. That pass is really only needed there if you've got nothing else in the function, because if we delete this line as well, we'll get an error down here because we don't have an indented block. But as long as you've got something in there, you don't need the pass. So let's change the volume of our audio bus, our music audio bus. For that, we want to do audio server dot, and it is set underscore bus underscore volume underscore dB. And then in brackets, and I've so just open the brackets here, and Godot's help here is telling me that it wants a bus index, which is an integer, and it wants a volume in decibels, which is a float. An integer is a whole number, a float is a decimal. Decimal. Got caught between decibel and decimal there. Okay, so the bus index is just the number of the bus from left to right. So at the left, you've got your master bus, which is 0, 1, 2. So in our case, our music bus is bus index 1. Now, you generally don't want to do that, and I'll show you a better way to get the bus index in a second, but just to prove that it's working, let's just put the index 1 in there. And I want to change the volume by, let's just quieten it right down, change it by -12 decibels. So this happens as soon as the game starts up, and we should find that our music is going to be really quiet. I'll save that, hit play. So yeah, there it is, very quiet in the background. If I was to change that to bus 2, save and play. The music's loud, and our sound effects are very quiet. But like I said, that's generally a bad idea. And the reason why, audio here. The reason why is that at the moment that's 0, 1, 2. But say we come in later on, or somebody else comes in later on and does this, just, for whatever reason, maybe they're just trying to make this layout sort of, a bit kind of neater and make more sense. Or maybe they stick another bus in somewhere and it changes the index of all of these buses. And so really, what we probably should make sure that nobody changes and rely on is the name of the bus rather than its index. And so in order to get the name, to get the index of a bus from its name, what we need to do, instead of having 1 or 2 there, is say, hey, audio server dot get underscore bus underscore index, open and close bracket, and it wants the name in there. So we're going to say get the index of the music bus. Let me just try and widen this out a bit so we can see it. No, that's as much as we can. Oh, there we go. Scale down my thing a little bit. Okay, we can't see the whole line anyway. So yeah, now we're getting the, since we can't see the whole line, I may as well at least make it so you can read what we can see. There we go. Yeah, so setting the volume of the of this bus, the music bus, which we're getting the index of, and setting it to -12. Make sure I haven't stuffed anything up. Yep, there's the music bus, nice and quiet. Now that's something, that bit of script you generally want to tie to a volume slider or something, right? But that's sort of out of the scope of today's tutorial. Okay, so you might also want to be able to turn an effect on a bus on or off. You probably, through script, are less likely to be kind of trying to tweak specific values of an effect, but just turning it on or off, like when our player runs into that echoey cave or leaves that echoey cave, is something that you're quite likely to find yourself wanting to do. And to do that, we just say audio server dot set bus effect enabled, and this wants a bus index, it wants an effect index, and it wants a value, whether that's on or off. So again, we could just say a bus index number, but a better way to go about it is to say, let's get the bus index by its name. In this case, we want the effects bus. Then we want a comma. Now the effect index, let me just pop back here. The effect index is sort of the order here. And as far as I know, there's not a way to get it by name. So we just need to remember not to mess around with the order of these things, I guess, which is a bit unfortunate. But yeah, again they start at 0, so our reverb is effect 0. So we put that there, and then we're just saying that we're going to, on startup, we're just going to turn the reverb off. So we're setting that to false. Let's save that, give it a run, and make sure that we don't have any reverb. So it's still quiet. That line that we did that turn the music down is still working. But our part and tiff have got their reverb turned off. Change this to true rather. Give it a run, and the reverb's on. And so yeah, as I said, you sort of trigger this line of code, the set bus effect enabled, when the player runs in or out of that kind of echoey space. Okay, and I think that's enough for today. Hopefully that's been enough of a start into Godot to kind of help you figure out how to make your own weird and wacky and wonderful things for the Audio Game Jam. and I look forward to seeing what you create. Thank you very much. Bye.
Today's tutorial is an intro to Godot for Unity people. No, it's not. It's not that. How to play a sound in response to an... What's that about?